Let's talk about subset sum problem. So this problem is from Geeks for Geeks. Actually, I'll show you just right here. And this is given a set of non-negative integers and a value sum, determine if there is a subset of the given set with sum equal to given sum. So this is the problem statement, and these are the test cases. So let me simplify it for you. First of all, we are given an array like 1, 2, 3, and we are given with a sum, let's say 4. You have to tell if it is possible to make a subset out of this set that is going to sum up to the given sum. So we can easily see 1 and 3, 1 and 3, they sum up to 4. So output is going to be true. All right, this is it. This is the problem. If we had 5 in case of 3, then it was not possible to make any subset that is going to sum up to 5, and then output would be false. Simple. This is it. So let's talk about the approach, that how we are going to solve this problem. Before I start, I should suggest you should pause this video right here and try this on your own. But after that, I am still here. So let's start. What's the most naive thing that you can think of? What is the most naive thing that you can think of? You can just traverse all of them. Traverse all of them. So how you are going to traverse all of them? Like we have ARR equal to 1, 2, 3, and sum equal to 4. How you are going to traverse all of them? So let's see an approach. We will traverse by here. Like first of all, we will see 3, then we will see if it is possible to make a subset out of 3 that is going to sum up to 4 or not. And if it's possible, then we will move on to next element, 2. Then we will check if it is possible from 2 or not. From 2 we will check for 1, like this. Does this sound familiar to you? Like, see, this node is like if we included 3 in our subset or not, then this is for no, then this is we included, this is not, and then furthermore same as that. Okay, so what is happening that we are checking if 3 could be included in the subset or not, and if not we will go to this node. So let's see, if we started with 3, okay, sum here was what, 4. All right, we moved here, we included 3 in our subset, then sum became what, 4 minus 3, that is 1. Now see, 1 is greater than 1 is less than 2. All right, 1 is less than 2, so we cannot have 2 in our subset if we have 3 in it. So we will not go to this node. Okay, we cannot include 2 because we want sum equal to 4, and if we include 2, the sum will become 5, which is greater than that. So we traverse down to this node, and at this node we can include 1, so we included 1 and we got sum equal to 4. So perfect subset 1 and 3, we traverse it back and return true. But furthermore, what we observe from here, we did we solve the same problem again. We solved subset is possible for this subtree or not, and from here we included this, so we solved this for a whole problem. So what we did, we actually built a recursive tree. See how this is a recursive tree, because uh, for every point that we did not included in our system, we actually made a choice that we include it or not. So first of all, what we have an array, we have sum, and let's take another third thing, that is n. It is nothing else but length of this array. Understood? So let's try building our function for finding the subset sum. So let me change the color. Okay, this one seems fine. Suppose we have a function subset sum. Okay, we have array, we have n, that is length of array, and then we have sum. Okay, cool. So for recursion we need a base condition. We need a base condition, right? So we will come back to this portion later. For now we will focus on the easy part. Okay, easy part would be, see, if last element, uh, let's call this last element le equal to arrays n minus 1, right? This last element is last element of the array. Now we have two conditions. Okay, we have two conditions for choice. If this last element is less than equal to what, sum, then only we will have that choice to either include it or to exclude it. All right, so this choice, how we will write this choice, we will say return subset for the same array, but see, wait, we have, see, this is right, we have to, sorry, the array's name should be same. Okay, subset sum for same array, and but one index less, one index less, and then same sum. This is what condition, this is the condition for excluding that element. But if you want to include it, suppose we want to include it, right? So what we will say, to include it we will do or of same function subset sum of arr, and then we will do one index less, and then what we will do, we will do sum minus last element, because we actually included that last element in our subset to check if the answer exists in this subset or not. All right, so we will subtract that last element from here. See what we did, we included 3 in it, so sum became 1, right? So this is the code for that. Otherwise, otherwise, okay, otherwise, else what will happen, we do not have a choice because sum is lesser than the last element. So in this case we do not have a choice. The only option we have is to exclude it, right? And for exclude we have already written the code. So we will do subset sum arr n minus 1, and then sum. Because the element is greater than the sum, we cannot have it, so just throw it away. All right, now coming back to the base condition, what will happen in base case? So for base case, let's think of the simplest problem. See, suppose if the n equal to 0, wait, huh? Suppose n equal to 0, this means ARR, our array, is an empty array. For empty array, suppose for empty array, if we have sum equal to even 1, we cannot make a subset out of empty array that will sum up to 1. So no matter what the size of what the value of sum is, except 0. Okay, because if we want sum equal to 0, we can just throw away an empty set. So if sum equal to 0, we will return true. Okay, this is the first base case. If we have sum equal to 0, we can return true directly, because no matter how the length of array is, no matter how big the array is, we will always return an empty subset that will sum up to 0. So if sum is equal to 0, we will always return true. But if n equal to 0 and sum not equal to 0, see, sum is not 0, we need to return something, even if it is 1, because non-negative integers are not part of this set. So if sum is not equal to 0 and n is equal to 0, means the length of the array or the set is 0. We cannot have that. Okay, we cannot make subset that will sum up to 0, so we will return false. So that's it. This is the entire thing. Okay, uh, I'll write it a little fair. So this is it. Uh, we have this array, then we have n, then we have sum. Okay, n is nothing but length of this array, and then this is the base condition. Okay, this portion is the base condition. If we have array of size 0 and sum is not equal to 0, because if array is empty array and sum is not 0, we will always have to return false, because see, suppose we have empty array and sum is having value like 2. Okay, how will you make 2 out of empty array? Never, right? So this will return false. But if it was 0, we can make it, because empty array will sum up to 0. So sum of empty array is 0. But if sum is equal to 0, then we can return true, because empty array will return 0 too. So we will have true value. Okay. Now these, if last element of the array is less than sum or equal to sum, then we will have choice. Okay. We will have choice to include it or to exclude it. These include and exclude are nothing but the recursive calls. And if we do not have that, we will have to exclude the element. We do not have a choice at all. And in next video we will have to think of a better solution. But this is the code for a recursion to solve this problem, although it is not optimal. But in next video we'll look at a more optimal solution for this